Yeah, welcome, dear students. The next topic is related to simplification using K-maps, and this is CDT7 of your OBLS lecture schedule. Now, in this session, this will develop knowledge on simplification of Boolean functions using K-map method or format method. See, K-map is a diagram made up of squares actually, and each set or square represents one minterm. And any function can be represented as sum of minterms, as you have seen in the previous session. So, of course, definitely you can express any function in the K-map also because each cell corresponds to one minterm in a K-map. So, if you just combine those minterms, it results a function. So, every function can be represented using a K-map because every cell of the K-map is equivalent to one minterm. And by various patterns, you can combine the ones and to get minimum number of literals or to get the minimum number of products. This is our main aim. So K-map is basically used for K-map is used for simplification of the given expression. So what do you mean by simplification? What do you mean by simplification? Less number of product terms in the result. As well as another thing is less number of literals in each term. What do you mean by literals? Suppose, for example, if I consider A bar, B, C bar is one term, product term. Here, A bar is said to be a literal. B is said to be another literal. C bar is said to be another literal. So this is what the definition of a literal and a product term. So the main aim of the format map is used for simplification and which results a less number of product terms, and each product term should have minimum number of literals. This is what is simplification. And there exist different types of K-maps based on the number of variables. If there are two variables, so the number of cells used in a K-map is 4, 0, 1, 2, 3. This is how it is represented. So A is one side, B is another side. Possible values of A, 0 and 1. 0 is represented with A bar and 1 is represented with A this side. And possible values of B, that is B bar, B respects to 0 and 1. And what is the decimal equivalent of these cells? So if I type 0, 0, decimal equivalent is 0. 0, 1, the decimal of this one. 1, 0, the decimal equivalent is 2. 1, 1, the decimal equivalent is 3. This is how we predict the decimal equivalent of the corresponding cell in a K-map. So the two variable K-map, two variable, if there are two variables in a K-map, how many cells does it have? 2 power 2, that is 4 cells. If a K-map has three variables, it has 2 power 3, that is 8 cells. This is important point you have to remember. Example, two variable K-map. Now let us map Boolean function y is equal to a plus b. And first truth table, it is simple OR operation. So 0 plus any 1 will be the 1. So 1 plus anything will be the 1. If both inputs are 0, output is 0. So how do we represent this? So how many variables are there? 2. For the 4 cell K-map, because 2 power 2 require 4. This is the pattern already you can see. Now, for which combination of the input, the output is 1? 0, 1, 1, 0, 1. So 0, 1, 1, 0, 1. So 3 ones are there in the output column. 3 ones are there, so represent that. This is how we represent a function in a K-map. Next, if the number of variables are 3, so the possible values would be 8, starting from 3 zeros and ending with 3 ones. The corresponding minterm is M0, M1, and up to M7. That is its decimal. Now coming to the K-map, it is very important. Of course, we know it is a 3-variable K-map. So 8 cells are required, but how does 8 cells are placed? A is one side, its possible values 0 and 1. B C is another side, possible values 0, 0, 0, 1, and 1, 1. This is very important. After that, 1, 0. So why we have taken 1, 1? Why not 1, 0? Actually, according to sequence, you will be getting 0, 1, then 1, 0, then 1, 1. But we are taking 1, 1 here because this K-map uses a gray code principle. Gray code principle. What is gray code? If you observe any two consecutive numbers in a gray code, suppose if it is a 2-bit, there is only 1-bit variation, right? So if you consider these two, this bit is same. If you are considering these two, only 1-bit variation is there, remaining same. If you consider these two, this bit is same. This is what a gray code is. So K-map uses a gray code principle, that is, two consecutive binary numbers should differ only by 1 bit. So this is A bar, and this is A, B bar, C bar. Okay? So 0 means B bar, again 0 means A bar, B bar, C, because C is 1 here. This is B, C. B, C bar, because C is 0, so that's why we are keeping complement. This is A bar, and this is A. So what is this cell corresponds to? A bar, B bar, C bar. That is what it is written. Similarly, A bar, B bar, C. And this one is A bar, B, C. Right? This is how we write the product terms of each cell. But the thing is, you have to remember it follows the gray code principle. So the next minimization is in the K-map. How do we minimize the K-map? First, construct the K-map, enter the ones in those square corresponds to the min terms for which the function values logic 1. Remaining will be empty. Now examine the map for square that cannot be combined. That means the ones which cannot be combined with any other squares, right? And form a group of such single squares. First one, right? Now look for the square which are adjacent to only one other square. So next you need to look for one which has only single adjacent. First one is no adjacent, which is also called isolated. Second one is single adjacent, which has only single adjacent one. This is called a pair. Next, continue with the squares result in groups of 4 squares, 8 squares. That is 4 square means 4. 8 square means 40. So first group the squares which results in 8 squares as a group of 8 squares is complete. Then form more squares, chords, outlet to include those squares that have not been grouped. And use only minimum number of groups. This is also very, very important. Have to use the minimum number of groups. So you'll be understanding clearly when we are solving the question. With the redundant group, and finally sum of all the remaining products. Now, when you combine two squares or two ones, one variable get eliminated. These two squares is said to be pair. So pair eliminates one variable. When you group 4 squares, that is formed, eliminates 2 variables. That is, if you combine 8 squares, that is said to be octet, which eliminates 3 variables. Simplify the function. F is equal to A plus A bar plus A bar 2. So very simple. Sigma of AB. AB means 3 actually, not 1. This is not 0 and this is 0. So it is done 2 and 3. So put 1 in those square boxes. That's representing the function is A. So let's simplify. How do you simplify? Look for the one which has single adjacent. So there is no one which has no adjacent. That means isolated one. So first step is isolated one. Is there any one which has no adjacent? No. I can combine these two because there is only one adjacent. So when you are combining ones, you need to follow adjacency property. So combining ones, at least there should be 1 bit variation, at least. Some cases, right? So at least there should be 1 bit variation. So you can combine these two because only A is changing, B is common. So 1 bit is changing. So no problem. So you can combine these two. What is the result? Write the common variable, B is common. So you have to eliminate the variable which is changing. Next, what is the other thing that is left out? This one has to be covered. Combine these two. As a result, A is common for both. So that's it. All the ones are out covered. There is investment. Next, similarly for a 3-variable function, f of a b c is equal to 3, 4, 6, 7. Preparing the function in the k-line. This is not 3, 4, 6, and 7. First look for isolated one. That means the one which has no adjacent. No, there doesn't exist. So next the one which has single adjacent. So if you consider this has, you might be thinking that there is no one in the adjacent square, so there is no isolation. There is no there's a adjacent one, but this is also adjacent one because among these two ones, only 1 bit variation in there. That is, A is same, C is also same, and only D is changing. So you can combine these two. Similarly, you can combine these two. What is the result? Common variables is B, C for this, A, C bar is a common. That's it. All the ones are covered to stop combining. So final answer is AC bar plus AC. Similarly, another function we go through that can work on that. And if you're having any queries, post in our group. That's it from simplification of the simple bullet functions using K. Thank you.